A quarter circle is inscribed inside the trapezoid ACBO as shown. The quarter circle is tangent to the trapezoid at point T. If AC is 4 units and BT is 6 units, then what is the area of the quarter circle? I saw a couple of solutions of this problem online, and while they are mostly correct, they are way longer than it needed to be. There's a much quicker solution, and I will show you exactly that. Start by drawing a vertical segment from point C towards the side OB. This segment is perpendicular to side OB at the point I'm calling H. So if we let R be the radius of the quarter circle, then segment CH must also have a length R. Next, we need to use the intersecting tangents theorem, which states that two tangents of a circle that intersect externally have equal lengths. Since segments AC and CT are intersecting tangents, therefore they have the same lengths of 4 units. Now, this is the point where most people have different solutions. Many of them resorted to using quadratic equations to solve the radius, and I genuinely thought there's no need for that. It's too much time and effort when you can solve the radius using congruent triangles. So here's what we'll do instead. From the center O of the quarter circle, draw the radius towards point T. Since point T is the point of tangency, the radius must be perpendicular to the tangent line BC. Next, we will use the segment addition postulate. The length of tangent line BTC or BC is the sum of the lengths 4 plus 6, which is 10. And then here's the secret detail we need. Let this angle measure be theta. Obviously, we have formed the right triangle CHB with a leg measure R, hypotenuse of 10, and two angles that measure 90 degrees and theta. Let's take this triangle to the side for now. Additionally, we have formed another right triangle OTB with a leg measure R and two angles measuring 90 degrees and theta. Let's take this triangle out too. Notice that both triangles have angles measuring theta and 90 degrees. Moreover, each triangle has a leg measuring R units, which isn't situated between the two known angles 90 and theta. This means that the triangles are congruent by the angle-angle side, or AAS congruence theorem. And since the triangles are congruent, therefore their corresponding parts are congruent as well. The hypotenuse of triangle CHB is 10 units, so the hypotenuse of triangle OTB must also be 10 units long. Finally, we can now solve the radius r of the quarter circle using the Pythagorean theorem. The sum of the squares of the legs is equal to the square of the hypotenuse. Radius squared plus 6 squared is equal to 10 squared. 6 times 6 is 36. 10 times 10 is 100. Transpose 36 to the right side and make it negative. We get r squared equals 100 minus 36. 100 minus 36 is 64. Take the square root of both sides, and the root of 64 is 8. The radius of the quarter circle is 8 units long. Now that we got the radius length, finding the area of the quarter circle is just formality at this point. The area is 1/4 times pi times radius squared. Substitute the radius length, that is 8, into the expression. 8 squared is 64, and 64 divided by 4 is 16. The area of the quarter circle is 16 pi square units. If you enjoyed this video, I encourage you to click the subscribe button so you wouldn't miss my next geometry puzzle. Thanks for watching.